Hi everyone. We're going to have a demonstration from Spleen Lab shortly, so if you'd be able to come to the platform to see the presentation, please feel free. Okay, welcome back to Homeport. We are going to have a demonstration from Spleen Lab shortly, who will be talking us through the demo as it happens, then with some questions. But to start with, we're going to have Christoph Stoll from Dronig and DFS, who's going to be talking to us about the safe air traffic management system they are using to help facilitate these demos here at Droneport. So, Christoph, over to you.
Thank you very much, Louis. And a very warm welcome and a good morning from my side to everyone who's made it out to the Homeport today to view the demonstrations. We are very happy to be here today. And like Louis said, my name is Christoph Stolle, and I'm with the DFS Deutsche Flugsicherung. That's the German air navigation service provider. And I'm there in the Department for Corporate Strategy and Organization, and the subjects that I mostly work on are in regards to digitalization and innovation, and that of course includes the unmanned aviation as well. So I'm very happy that in my capacity as the project leader of the U-Space sandbox that we've shortly installed here in Hamburg over the last couple of months, that in that capacity I can talk to you briefly today about the UTM system of DFS and Dronig. So UTM, that is the Unmanned Aircraft System Traffic Management, and the system that we have in place is the first fully operational and commercialized system in Germany, and it builds the basis for the implementation of the European concept of U-Space. And yeah, we start with that here today, and both these things, the UTM system and the U-Space concept, build the basis to, in the future, ensure that even a large number of applications for unmanned aircraft systems can be deployed safely and in coordination with manned air traffic. And that especially in urban areas, such as the Port of Hamburg. So before I talk to you about what we actually do, I don't want to draw your attention directly to the sky. I would like to stay right here on the ground for a moment. To be more precise, let's just look at the roads and the streets for a second here, because there we have a large number of participants or users of roads and streets. We have cars, buses, motorcycles and cyclists, we have e-scooters and pedestrians. So that's a huge razzle-dazzle of different users that we have on the streets, and we have, of course, a set of rules in place in order to safely manage that traffic in the streets. And when we look up to the sky, it's sort of the same thing, but there only, not to all of us, these set of rules might be apparent immediately. So when we look up, the first thing that we tend to see is the open, free, unlimited sky. But of course, there are rules in place up there as well in order to safely manage the air traffic. And this safe management of manned air traffic has been our business successfully over decades now, so we're good at that. And now with the introduction of civil unmanned aircraft systems, there's a new player. So that means this traffic management is approaching a new era. We not just have any more manned air traffic, but also unmanned. And these unmanned vehicles, they have a completely different set of capabilities and needs in order to perform their operations. And they want to use the same airspace. So that creates the need to amend the existing set of rules that we have in place. So what we need to do is we need to combine these two worlds together. We need to integrate them into each other in order to facilitate a safe operation for everyone that's up there in the sky. And to solve these arising challenges, the DFS, Deutsche Flugsicherung, and the Deutsche Telekom have, in the year 2019, founded the drone specialist joint venture called Dronic. And our joint task is to fairly and safely integrate drones into the existing airspace. And you may ask yourself now, well, how does this work exactly then? And one very important aspect of it is actually as simple as it is important, and that's visibility. So visibility is paramount. So in order to perform safe flight operations, you need to have a live and reliable picture of what's happening up there in the air, and that at all times. And that's what we create for the drone users. Because one important aspect of both traffic systems on the streets and up in the air is that you're aware of the rules that exist, and also you need to know what's happening around you. Because only when you know what's happening around you, you can follow the rules and avoid the conflicts. So our task, one of our tasks actually, is now to make everyone visible, because the traditional radar stations, they can't capture drones because they're just too small. And also it's a great challenge from a cockpit of a manned manned aircraft to see drones, because they're just too small to recognize. And if we look at it from the other side, the drone pilot, he doesn't sit in his vehicle. He's a remote pilot that sits somewhere else and may fly his drone kilometers away. So we need to make them electronically visible. And that's especially important when we fly out of the visual line of sight. So when the drone pilot cannot actually see anymore where his drone is or what's happening around it. And that's important regardless of any use case. So maybe agriculture, energy, medicine, transport, logistics in general, or the transport sector. We need to make sure that everyone flies safely. And this is why our UTM system provides for authorities, drone operators, remote pilots, support through all phases of the flight. So that's pre-flight, in-flight, and post-flight. With functionalities like flight planning, flight authorization, we have conflict alerts, we have conformance monitoring, and in the post-flight section we have the documentation and the incident management, for example, if there has been any incidents. So this makes us achieve our goal or contribute to our goal to safely and fairly integrate drones into the airspace. So how do we actually make them visible? Well, we employ parts of the air traffic system of the DFS and also the mobile network of Deutsche Telekom. So the manned air traffic data is coming directly from the DFS system, so it's reliable and it's quality assured. And other traffic data is collected by special UAS hardware that's developed by Dronic. And that collects additional data, especially of unmanned aircraft. And well, you can make unmanned aircraft visible in many different ways. But just to give you an example, what we will present here today as well is employing the mobile network, so 4G or LTE network. So there's two ways to get connected to our system. This is either the unmanned vehicle is already LTE ready and we just can hook it up to our API and it sends its position directly into the system. Or you use one of our LTE transponders, like this one here. It's really small, weighs 35 grams, and sends the position of the UAS directly into the system. But it does not only do that. In addition to that, it also collects all the traffic that's in its vicinity in the air, and it forwards that traffic information into the system as well. So it acts like a relay station in the air, sort of like a flying eye. And in addition to that, it also communicates directly into the cockpit of the manned aviation and tells them the position of the unmanned vehicle too. So putting all that together, the manned and the unmanned traffic information, that will be then displayed to the drone pilot so that he's always aware of what's happening around him and he can safely perform his flights at all times and even beyond visual line of sight. And what that looks like, you can experience in just a moment when Spleen Lab, who have fitted one of our devices to their vehicle, will perform the demonstration. If you just take out your smartphone and scan the QR code that's on these little flyers that are distributed around here, you will be led directly to a basic web display of our UTM system that will show you the drone, and in case there will be any other traffic in our area here, that will be displayed as well. So you can check that out and see what the system actually looks like. In the main system, like I said, there are much more functionalities, so that's just the displaying system. So if you're looking for any more information on that or our current activities, I warmly invite you to check out the homepages of DFS and Dronic or visit the booth of the Federal Ministry of Transport and Digitalization at the ITS in Hall B4. We have prepared some information monitors there. And if you have any further questions, you may also, of course, approach me after this presentation. You're very welcome to ask any questions. And now I would like to hand back to Louis to get the demonstration on the road. And I always wish you blue skies, a bit bluer than today, and happy landings.
Thanks very much, Christoph. So, as we said, we're going to hand over now to Marion and Sebastian from Spleen Lab. As a brief introduction, Spleen Lab is engaged in the development of software for autonomous flights, drones, air taxis, and assistance functions for helicopters. So, Marion, would you like to take it away?
Thanks for your introduction. I'm Marion Seliger, and I welcome everyone to our demonstration of automated structural inspection. I hope the wind is not too strong that we are able to perform. I might give a short introduction to Spleen Lab, and the guys can start behind there. Spleen Lab is a software company, a specialized AI software company providing software for automated driving and flying. For example, detect and avoid, ground cruise estimation. And what we will perform today is an example of what we can do. We will inspect that floodlight tower behind there at the end of that area. The guys behind there are just for safety reasons. They won't interact while the drone is flying. Yeah, so they will start any moment if the wind is not too strong. So that it's a product we are, which is available from now in cooperation with Auterion and that Skynode, and it's capable for any kind of industrial-grade drone having Auterion Skynode on board, and it's quite easy to implement for that industrial inspection use case. What we can inspect with that is any kind of industrial infrastructure. With that floodlight tower is only an example We're also able to, for example, inspect some kind of turbines, wind turbines, cell towers, maybe that kind of crane you see in that harbor. The drone is now starting. He's now detecting the floodlight tower and the center of the floodlight tower. Then the drone will fly through that floodlight tower. Everything is automated, so there's no interaction from those guys. You see the drone now flying through that floodlight tower. And now the drone is in position and performs an automated orbit flight around that floodlight tower and providing some high-resolution images for inspection. We also have the collision avoidance on board, so the cube ensures that we don't collide with something that could be in the way. On the cube there is a Blickfeld LiDAR on board and a high-resolution camera. The LiDAR in that case is only responsible for the path planning and for the automated flying, and the camera to take some pictures, high-resolution pictures for inspection. If you're interested in that kind of solution, for the guys here at the stage, there will be some flyers everywhere around, and just get back to me. The drone now did its job and it's going back for landing. Yeah, everything went well. As I said, without any action from the guys on the ground. And that's done, actually. I now have a short video we did in prior to this exhibition. Actually, it's the same use case, just with some more pictures. And you see again, the takeoff, the orbit flight, and the landing, and some images of the LiDAR. So here again, the drone is taking off. That's not meant for marketing purposes. It's only to give a better overview of what we are doing and what the system is able to do. So here again, in point of view of the drone, it detects the cell tower in that case, and also performs an orbit fly. The orbit flight is only an example for the path planning. If you have like a wind turbine, another path planning, or of course, also could be implemented. Yeah, as again, the same use case, the solution available from now on. If you use Auterion, if you are a drone manufacturer, it's ready to go. What you've just seen was just a 3D map created by the LiDAR, but only responsible for the path planning and for the navigation. Okay, the drone is now landing again. Okay, that's done for the demo. Everything went well, luckily. Thanks for your attention.
Thank you. So a few questions now, and if there's any questions from the audience, please feel free to put up your hand. So we've seen sort of today and throughout the week, there's quite a lot of sort of industrial inspection platforms, hardware or software. Can you talk a bit about the USP, if you like, of your platform?
of our platform, the USP is that everything runs on that device. So all algorithms we provide are real-time capable and embedded on that drone. There's no communication to the ground station or something necessary. And yeah, actually that's it. So we have the aim to fly BVLOS, so automated, beyond vision line of sight. And yeah, for example, we have the collision avoidance in program, which we need for flying BVLOS, also ground risk estimation, and some other products like GPS-less navigation, everything running embedded and in real time on board of that little cube or on the drone if it's integrated. So that would be our USP, that we are on a really small form factor and everything runs on board.
Okay, and in the tagline you talk about safe machine learning. So when you're conducting an inspection and you're building these 3D images, for example, how do you then train the system or identify potential issues? Is that part of the service you're providing, or is it just handing over the imagery?
If I understand the question right, because it's pretty hard to hear because of the backlog or something, what makes it special? How we train the AI for it? Was the question?
Yeah, so once you have the imagery, if you like, so in this example with the floodlight, for example, you've collected the imagery, but then how do you identify if it's good or if there's a problem? Is that part of the service you provide, or are you just handing over the data to your client?
Yeah, that's also a service. We have those data provided by us. The data the drone needs by itself for flying, for automated collision avoidance, and something that's on the drone. So there's no V2X communication needed to any ground station.
And what you also maybe ask is how we use this data. We trained the AI before to several cases. For example, the ground risk estimation, which Marian mentioned, is that we can identify a safe landing spot. So with the help of the AI, the drone knows, okay, this is a house, this is a car, these are people, so I can't land there. But there's a free spot, there's not crowded, so we can bring a loading, or we can safe landing on the spot. So that's what we're doing. And also when you fly around like this light pole there, with the help of the AI, we know we can identify our environment easily and react to it. So if it's intruder which comes in our way, we can react. Is there something in on the way which is not identified in some maps? We can react to it. And it's also, everything is without a pilot possible. So it's like assisting system, but also the base for autonomy in the end.
Yeah. Okay, and just interested to hear about the history of the company, of Spleen Lab. How did you guys sort of get to where you're at now? What was the background and the thinking behind it?
Yeah, everything started by founding this company. Like we really started at 2018 and were able to really get into process in start of 2020. The know-how we are providing is coming from the automotive sector, and we just wanted to bring all this know-how into the air. Most of our engineers are also coming from the automotive, self-driving part. And yeah.
Given that you talk about a very sort of small module and something that's integrated, would there be a possibility for other drone operators to use your software and machine learning systems?
Yeah, our algorithms, our software is agnostic and modular. So every drone operator or every drone manufacturer can use the software. Any industrial drone, actually. and yeah, it's modular. We have different sensors. We are where we trained our algorithms with, like LiDAR, camera, ToF camera, infrared. But you don't need all those sensors for our algorithms to work. You can, like, for example, only use a LiDAR, only use a camera for whatever reason. And yeah, it's suitable for any kind of industrial grade drone.
Okay, so you'll act as a hardware and software provider to other service providers? I mean, in terms of the model that you sort of are using and
yeah, it's more like a software supplier. We definitely a software company. We have that cube just to enable our software, but we are not this hardware supplier. We are a software supplier.
But what we are doing is the integration. We help the manufacturers to integrate the software parts and the software parts in their drone, and also in combination with the sensor setup. But we are free in using any kind of sensors. Yeah, depends on what our customers need. So then we help with the integration. So yeah, as Marian mentioned, the cube with the sensor setup and the AI on board is a good vehicle to show how it works. But if you have yeah, like bigger drones or air taxis, you always will integrate the sensor setup into the drone. If you have a hexacopter or quadrocopter, there you can use this plug-and-play solution from us with in combination with software and hardware. So yeah.
Okay, so linked to that then, what are some of the differences if you're dealing with, you know, a small drone, a quadcopter versus, you know, an air taxi or a helicopter? Is it entirely transferable, or are there different considerations for each?
It's transferable. Actually, you always need to pay attention to the payload, of course. You can put too much weight, too much payload on the small drone. But actually, those devices are pretty light. That cube we put on that drone is below 500 grams. For air taxis, for BVLOS flight, if they aim the BVLOS fly, you of course maybe need redundant sensors and more sensors. But that's also our know-how. We fuse all them together and have it safe. So we put AI into the way that it's safe, but also have the another way for certification where AI don't come into place.
Okay, great. Started to rain quite intensely now. Are there any questions from the audience? Don't think so right now. Are there any final comments you'd like to tell to the people here at Homeport or for ITS Congress in general?
Yeah, you can find us in the startup area, booth 17. We will also have tomorrow, Marian will have a pitch in the startup area and also have a talk about safe AI for BVLOS flights on the Congress, in the Congress Center. So it's tomorrow in the afternoon, I think, like 4 to 5 o'clock. With Volocopter and some others, so come and join and ask more questions.
Yeah, tomorrow there will be the presentation and the talk in the for the audience again from my side. If anybody is interested, any drone manufacturer for that solution, for any other kind of solution, automated flying or some other algorithms we provide, just get into contact with me. And yeah, that solution we provided, we just shown the demo, is ready to use for any kind of drone, as I said, any kind of industrial drone, and pretty easy to integrate.
Great. So you can find Marius or Sebastian around the Congress. Thank you very much to Spleenlab and for the demo. And we'll wrap up this session for now. Thank you.
Thanks for the question, and thanks for having you.